I just recently finished a big project where I needed to create a large amount of randomly generated dungeons, so today I'm going to walk you all through some random map generation algorithms. When looking for the correct one, I went in depth through 3 different algorithm styles: random rooms, Prim's algorithm, and finally an algorithm of my own creation, the Skaven tunneler. The first algorithm I attempted to use was an algorithm that randomly presented rooms to the player who could then choose between them. This is the easiest way to create a very basic dungeon system, but it makes it more difficult to track and then save the previous rooms and could lead to some flavor errors. The easiest way to implement this style is with an enumerated data class, where you choose a few rooms and offer them up to the player. Once the player clears the previous room, congratulate them, then offer them a new set of rooms. This would be an easy solution, but wouldn't really provide that much depth and rely a lot on match functions. It also may not seem completely random, and the player may find themselves between just a few different types of rooms. Still, plenty of successful games, Python or otherwise, use some sort of procedural room generation, like the original Rogue, and more modern games like Binding of Isaac. So let's check out the next algorithm. Prim's algorithm is a minimum spanning tree algorithm that builds out a map through finding the closest points to one of its included vertexes. The first vertex that is chosen initially becomes part of the map, then the shortest possible path is taken to the next vertex. From there, the algorithm continues by creating the shortest possible paths from any vertex in the current map to a vertex that is not currently in the map. In an ND array, Prim's algorithm creates a random map by randomly choosing vertexes to move to, then builds out the map in an extremely unpredictable manner. The best part of Prim's algorithm is that a programmer can use the theory to easily build a high-level algorithm to implement in their program. Unfortunately, the implementation itself is not the best for Python, as it tends to take quite a long time, as it has to check each possible vertex for the shortest path. This can lead to inefficient use of code and the program running longer than it needs to. It is also not used very often in games for general, not only for its lack of efficiency, but generally as it is not as useful as other possible algorithms. Now, let's take a look at the final algorithm. The final and selected algorithm I looked at was a variation of a worm algorithm, which I dubbed the Skaven tunneler. The Skaven begins by selecting a random edge of the map, then burrows through an ND array until it hits an edge. To make the maps dynamic, the Skaven has a 1 in 4 chance of turning left or right for each cell it burrows through. Then, once a Skaven dies by hitting a wall, another will take its place, until the number of Skaven tunneled is the number specified, which for me was 6. Once all of the Skaven have burrowed through the array, then the random point generator begins. The random point generator selects between 4 and 6 points on the map and assigns them as action zones. These action zones will, when the player steps on them in navigation mode, perform several tasks, include starting a battle, opening a shop, and finding experience and loot. The positives of this algorithm is that it can be easily applied to a physical example and can be translated easily to pseudocode, but the actual map itself is quite limiting. This option worked extremely well for the purpose I used it for, but wouldn't work as well for real-time games, or games that require a more intricate map, perhaps using multiple levels of elevation. It is an easy but fairly limiting approach. Of course, these are not the only ways to implement random dungeon map generation in your Python games. You could use random walkers, or other variations of a worm algorithm. Even other algorithms like Prim's could work just as well, but these are the ones I've attempted to use. Please, if you liked these algorithms, consider making your own game and implementing them yourself. Have fun coding, folks, and good luck. This is Tom, signing off.